right, I'll give you some hints. See, first of all, in this circuit, we are given a combination of different capacitors, and we are required to find the potential difference between M and N. That is the potential difference across this capacitor. So to find this, we first have to calculate how much charge is being distributed along these capacitors. And to do that, just a second, guys. Okay, I think we have got some new members, so I'll give 1 more minute to solve this question and then we'll continue with the solution. Let me know if anyone gets the answer. Okay, we have Anish who has joined right now. Anish, try solving this question. Alright, let's continue with the solution. See, we can see here clearly that 2C, 3, the C and 2C are in a series. So for a series combination, how do we calculate the equivalent capacitance? It is calculated as 1 upon C1 plus 1 upon C2 plus 1 upon C3, and that is 1 upon 2C plus 1 upon C plus 1 upon 2C. That gives us 1 plus 2 plus 1, that is 4 upon 2C. So equivalent capacitance of this combination of these three capacitors in series will be C by 2. Alright, so this structure can be written in a simplified manner as alright, is anyone having any doubt till now? Alright, and now these two capacitors are in parallel. So for parallel combination, equivalent capacitance is just simply the addition of both of them. That gives us 3C by 2. So the structure finally comes out as 3C by 2 and a 60 volts given at its ends. Now we have simple formula Q equals to C into V. That gives us 3C by 2 multiplied by 60. That is 90C. Alright, that means 90C charge has been given by the potential. So 90C plus and minus 90C has been developed on this capacitor. That means this A over here has given out a total of 90C charge. Now this 90C charge gets distributed in this and this. So in what ratio are these going to get distributed? It is simple. We know that Q equals to CV. That means Q is directly proportional to C, and as this is half of this capacitor, so half charge will be given towards this branch, that is 30C, and over here will come 60C. Alright, यहाँ तक clear सबको? Next what we are going to do is, this branch is receiving 30C. We have to deal with only this one. So what we had originally is this, means over here 30C has been given. So 30C over here and minus 30C over here, then plus 30C and then minus 30C and plus 30C and minus 30C. So this capacitor across which we have to find the potential difference is having a capacitance of C and charge of 30C. So by the formula Q equals to CV, we have V equals to Q by C, which comes out as 30C upon C, which gives us 30 volts. So 30 volts is our answer. That is the option D. Is the solution clear to everyone? Or shall I explain again? What did you do after Q equals to 90C? Alright. See, first, just a second. See, we got Q equals to 90C, which was actually the total charge that was given out by the potential difference, by the battery. Now this 90C charge is being distributed in this branch and this branch. Alright, see, it is going in over here and over here. Now we have to reach on this capacitor, so we need to find how much charge is being developed over here. So to find that, we calculate the total capacitance of these three. That came out to be as C by 2. So we had this structure. Wait, let me make this again. See, 90C is coming from over here, and charge is directly proportional to the capacitance of the capacitor. Like जितना ज़्यादा कैपेसिटेंस होगा उतना ज़्यादा चार्ज वो स्टोर कर सकता है. So by that concept, we know that C by 2 is going to have half of the charge which is getting stored at C. Alright, तो ये 90C को अपन कैसे डिवाइड कर सकते हैं कि ये कंडीशन सेटिस्फाई हो पाए. So you can use the concept of ratio as well, but I think it is quite clear. We can do it easily, and this will come 30C and 60C. Alright, इन दोनों का एडिशन हमारा 90C होना चाहिए. यहाँ तक आया समझ में? Alright, and इसके आगे Q equal to CV का फॉर्मूला लगाया, and using which we found out V equals to Q by C and 30 um, yes 30C upon C. यहाँ पे C क्यों लिया? क्योंकि हमें ये C जो एक्चुअल क्वेश्चन में जो है कैपेसिटर, इसके अक्रॉस पोटेंशियल डिफरेंस निकालना है. So this gives us answer as 30 volts. Alright, let's move on to the next question. The electric field intensity at a point at a distance 2 meters from a charge Q is E. The amount of work done in bringing a charge of 2 coulombs from infinity to this point will be. Just to remind you, when we are talking about work done, then we use the concept of potential and potential energy, whatever is useful. I'm giving you 2 minutes to think about this question. Let me know if anyone gets the answer. Anyone who could not understand the meaning of the question? No, A is not the answer. Yes, B is the right answer. Anyone else with any answer? See, this is a fundamental question. This is the definition of potential, guys. The work done to bring a charge from infinity to any point is called the potential energy at that point. And how do we calculate potential energy? It is given as charge multiplied by the electric field. So that will come out to be, just a second. Anyone else with the answer? Let's wait for a minute. All right. Has everyone got the answer? Right, let's move on to the next question. The electric potential V is given as a function of distance x by V equals to 5x squared plus 10x minus 9. And we have to find the magnitude of electric field.
Sir, are you doing anything?
No, just a second. Okay. Everyone get this answer? See, for this question, what we need to do is there's a simple relation field equals to dv by dx. That gives us E equals to 10x plus 10. Alright, so now we just have to substitute x equals to 1. That gives us 10 plus 10, that is 20. A is the answer. And yeah, the previous question. See, V is given as Q upon 4 pi epsilon naught R. That can be written as R into E. So V comes out as 2E, as R is given as 2 meters. So the amount of work done, that is, sorry, this is work done. Work done will be given as Q is 2 coulombs, so 2, and the potential will be 2E. So that comes out as 4E. B will be the answer. Alright, let's move on to the next question. ये वाला आगे सबको समझ में इलेक्ट्रिक पोटेंशियल वाला. Alright. Guys, try this question. See, this one is quite easy, as the triangle given is an equilateral triangle and the charges are also equal. So, yes, Ganesh, you're right. The answer is D, 0, because this, the centroid O is equidistant to all the three vertices. So the distance, that is R, is same for all of them. So the field will also come out to be same, and in the direction such that all of them will cancel out each other. Is this one clear to everyone? three charges, capital Q and two positive small q, are placed at the vertices of a right angle triangle. And we have to find the value of capital Q such that the net electrostatic energy of the configuration comes out to be zero. The, the electrostatic energy means potential energy. So we basically have to calculate the potential energies of the complete system and equate it to zero. No, D is not the answer. Alright, let's form the equation. No, A is also not the answer. Yes, B is the answer. Let's take these two first. So the potential energy comes out to be K Q Q by A. See, this is A and this will be A because this is an isosceles triangle. And this is 90 degrees, so this length will be root 2A. So for these two charges, the potential energy is this, and for this and this charge will be QQ by root 2A, and for these both charges will be, now this has to be 0, so we can calculate the following equation. The A will also get cancelled out, and we will have a relation in capital Q and the small q. That will be a root 2q plus q is root 2 small q. The answer will come out to be this. Alright, let's move on to the next question. Four charged particles of charges, three of them are minus q and one is positive 3q. These are placed at the vertices of a square of side A. All of these are A. The magnitude of dipole moment of the arrangement is, see, a dipole moment is formed when two opposite charges of equal magnitude are taken together. So for each minus q, we have to take a separate plus q, and we have to form dipoles of all of them. Alright, and take the directions carefully. Like the dipole moment for this length will be towards here, dipole moment for this combination will be here, and a third dipole moment over here. So we'll have to find the resultant of these three dipole moments. Try doing this, guys. The, here's the answer to this question is A. Yes, A is the right answer. See, an easier method to do this can be first find the resultant of the two outer dipole moments. This will come out to be in the same direction as this one, and that will be a square plus a square whole square root. That will be root 2a, and the dipole moment will come out to be root 2a into q. Alright, so first we have root 2aq, and the one in the middle in the same direction, that is the diagonal is root 2a, so it will be root 2aq. So the total will come out to be 2 root 2aq. That is the first answer. सबको आया समझ में?
Did you do for the top left and bottom right charts?
I'm sorry, please repeat.
What did you take for the top left and bottom right charts?
Top left and bottom right. See, this is minus q and minus q. So this 3q will be divided into three parts for all of them, because see, equal charges are needed to form the dipoles. So we have taken three dipoles, that is minus q and plus q over here, and then one minus q and plus q again over here, and another plus q and minus q over here. आगे समझ में? So we have formed this dipole, and this dipole. Clear to everyone? All right, let's move on to the next one. A non-conducting ring of radius r. See, there is a ring with radius r. It has charge q distributed uniformly over it. Like suppose there is a positive charge all over it, and this total charge is q. If it rotates with an angular velocity omega, okay, this is rotating with an angular velocity omega, the equivalent current will be. इक्वेशन समझ में आया क्या सबको? See, if a charge is moving, then it will give result to a current. All right, because total charge that passes through any point in any wire or any place per some unit time, that is called current. That is I equals to total charge upon total time. All right, try doing this. Yes, C is the right answer. Yes, C is right. Has everyone tried solving this question? All right, see, the total charge in this situation is Q, and we have to find the total time it is taking to cross any random position, suppose this one. So, how much time is it going to take for a ring to complete one circle that is given by the time period? So, we know that time period T equals to 2 pi upon omega. So, this can be written as Q upon 2 pi upon omega, which is Q into omega upon 2 pi. That is the C option. Is anyone having any doubt? Alright, let's take the last question of today's session. Just a second. Alright, try solving this one. Yes, the answer is A. Yes, A is the right answer. Alright, let us try solving this question. See, in questions like this, where there is a complicated set of different devices, what we do is we name different points. Like this point will be called A because the potential is same over here. This will become A. This is B, so this will also be B and B. Now a device has come over here, so we'll change the name. Let us call this C and D. Now we will try to open this structure. See, there is a 3 microfarads between A and C, 2 microfarads between A and D, 5 between D and C, 6 between C and B, and 4 between B and D. Now we can see over here that 3 upon 6 is equal to 2 upon 4. Alright, both of them are equals to 1 by 2. This is the condition for the Wheatstone bridge. And when the condition of Wheatstone bridge is satisfied, we can remove the central device. Over here it is capacitor. Alright, so this capacitor can be removed from our calculation, and therefore our structure will get reduced to a very simpler manner, that is 3 to 6 and 4, and we have to find equivalent capacitors between A and B. So this 3 and 6 are seen to be in series, and this 2 and 4 are in series. So 1 upon 3 plus 1 upon 6, that will become 3, 3 upon 6, that is 1 upon 2. So this will come out to be 2. Similarly, 1 upon 2 plus 1 upon 4, this will become 3 upon 4, and inverse of it will be 4 upon 3. So now what we have is a parallel combination of two capacitors with 2 and 4 by 3, and when it's parallel we add both of them. So 2 plus 4 by 3, that will be 6 plus 4 by 3, that is 10 upon 3 microfarads. Is this question clear to everyone? All right, thanks for today. Thank you, everyone.